In this lesson, we're going to put fractions in lowest terms, and we'll start with 8/12. Both of those numbers are divisible by 4, so it can be changed to 2/3. And now let's look at 8a squared divided by 12a. Well, the 8/12, of course, is 2/3. And from what we already know about exponents, we know that a squared over a is just a. So we end up with 2a over 3. And it's worth noting that in order to put this fraction in lowest terms, we need to assume that a is not 0. Now a little more complicated. We have a b in our numerator and a b squared in our denominator. We put it in lowest terms, 2a over 3b. And again, a may not be 0. b also may not be 0. If either one is 0, we'll have division by 0, which is undefined. And in this final example in this frame, we've added a binomial. But a binomial over itself, as long as it's not 0, is equal to 1. So we can cancel an a, we can cancel a b, we can cancel the a, take away 3's, and of course, for the 8/12, they each had the common factor of 4, giving us 2a over 3b. And in this case, a can't be 0, but it also can't be 3, because if a was 3, 3 minus 3 would be 0. And of course, b still cannot be 0. We often assume that denominators are not equal to 0 when working with algebraic fractions. And what this means is that we won't take the trouble each time we work with an algebraic fraction to state what the variables are not allowed to be. But in many formal settings, it's required that you state what's known as the restrictions of the variable. And these are the values that would keep denominators from being 0. But we're going to make the assumption in all of our subsequent problems that our denominators are not 0. So now we have a binomial on the top, a trinomial on the bottom. We can factor each one of these. We have a difference of squares, and then the trinomial just has a pair of factors. And we can cancel the a, take away 3's. And our final lowest terms fraction is a plus 3 over a plus 6. I've left the parentheses on, but they are not necessary. Now we have one. It's a product of a monomial and a binomial, and then in the denominator, the product of a monomial and a trinomial. Well, the first thing we can do is find common factors in 9 and 15. Each one is divisible by 3. And then the a to the third over a leaves us an a squared on the top. And now we factor. And after we factor, we have the common factor, a binomial, a plus 1 on the numerator and the denominator. So they're gone. And then we look to see what's left. And we have 3a squared times the binomial a minus 1 on the numerator, and 5 times the binomial a plus 6 in our denominator. Here's one. Again, we can find the common factor of 3 in the 15 and the 9. We can find 3 powers of a that they have in common, leaving a to the first on the bottom. Now we're going to factor our binomial in the numerator and our trinomial in the denominator. And we still have some more monomial factors. We now have a pair of 3's, one in the numerator, one in the denominator. Another a has popped out in the numerator to take out the remaining a in the denominator. And then they each have a common binomial factor of a take away 1. Now we have to carefully look and see what's left. In the numerator, just a 5. And in the denominator, just an a minus 6. You may have also noticed we got a little casual, and we marked out common factors where the entire factor was marked out. We did not replace it with a 1 this time, and that's just for showing our work. However, if all of the factors get marked out, make sure you put a 1 in. Don't just leave it blank. That's important. Well, what's left in this particular fraction is a 5 in the numerator and an a minus 6 in the denominator. It's a lot simpler now than it was in the beginning. Here's an 8 over negative 8. I hope you all know that that's equal to negative 1. Here's an n over the opposite of n. I hope you all know that that's equal to -1, of course, provided that n is not 0. And here's 8 minus 6 over 6 minus 8, which of course is 2 over -2, which of course is -1. And now we replace the 8 with an n, and you'll realize that as long as n isn't 6, that any number take away 6 is the opposite of 6 take away that number. So in lowest terms, it's -1, provided in this case that n is not 6. That brings us to this expression. A take away b over b take away a. Once again, pick any two numbers you want. The first number take away the second number will be the opposite of the second number take away the first number. Therefore, they simplify to become -1, once again, provided that the two numbers are not the same. Well, let's use this fact in our next longer problem. We're going to start by looking at the -21 and the 7. They're each divisible by 7, leaving a -3 at the top. And again, we got casual and did not write the 1 at the bottom. We look at the a to the third and the a to the fourth, leaving an a at the bottom. Now we factor the binomial at the top, giving us an a squared, times the binomial b minus a. We factor the trinomial at the bottom, which turned out to be a perfect square trinomial. Now we see we have an a squared at the top, and we have the a left over at the bottom, so we could cancel those out. And what we have at the top now is a b minus a, and we see we have an a minus b at the bottom. And from our previous couple of frames, we now know that those are opposites. So 1 gets crossed out. You can write a 1 there if you want, but the 1 on the top, when it gets crossed out, since they're opposites, we need to make it a -1. And now we very carefully look at what's left. On the top, we have a -3 and a -1, and on the bottom, just an a minus b. Well, the -3 times -1 makes 3 on the top, combined with the a to make 3a, and on the bottom, we just have a minus b. So once again, our fraction in lowest terms, much shorter and simpler than the original fraction. To simplify an algebraic fraction that contains variables, mark out common factors in the numerator and denominator, and apply the rules for quotients of powers with equal bases. When polynomials are present, factor the polynomials, then mark out common factors.